Good job. Yeah, this one. So the reason for that is that in here, the sample spans few units, so each unit has to be large. And now that the sample grew, it spans more units, but the total size of this has to remain the same as this. So since it spans more units, each of these have to measure less than they do here. And then if you do the math, in here it spanned 10 units, each of these units was 25. So the sample size is 250 micrometers. And then when you moved to the 10x objective, it spanned 25 units. It still has to measure 250 micrometers. And the only way it could match that numbers if each unit was 10 micrometers. So this one is the one that is right. Now, how do people know how much each of these guys measures? Well, the way that people figure this out is something called reticle calibration, meaning this is a ruler in your eyepiece. And then on this page, on this slide, instead of having a sample that you don't know its size, you use something you do know the size. So in real life, I'm going to draw a reticle calibration, and then this will be your table 2 in the lab manual so that you know how to fill it out. And you don't have to memorize that table. You just need to know how to use it when in an exam or in the quiz next week. I give you a sample, I give you the little ruler, and then I ask you how big is the sample. So maybe I'll start there, because that's the type of question I'll ask in the future. The filling out of the table is just me teaching you how to do a reticle calibration, but you most likely won't have to do that. It is more for like math enthusiasts, which I'm one of them, and if you empathize, then you're like, hooray, and then if you don't, you're like, okay, don't worry, now I'm gonna have to do this again probably ever in your life. So let's say here is my ocular reticle. We'll pretend I'm doing a good job here. Okay, just pretend that this distance is 10 between the major tick marks. All right, now I'm going to draw something beautiful. Let's see. This is my version of something beautiful. All right, some amoeba or something like that. Okay, then you go like, all right, this thing spans from like here to here. Then you go, it is 10, 20, 30, 40, I don't know, 45 units. And then I ask you, how large, and type this. This is this type of question I'll ask you in homework, I'll ask you in exam. How large is the amoeba? Put on the chat. Or better, I'm gonna do a poll so that you don't feel too shy. Okay, so answers will be that. All right. So a lot of you fell for my trap because I'm so even. Okay, the right answer is, I don't know. It should be mad at me right now because, people that wrote I don't know, hopefully you know why you don't know. And the reason why you don't know is that I didn't tell you, I showed just 45 units, but I didn't tell you how large are the units, so I cannot tell it in micrometers. And for me to know that, I need to know what objective am I using. Because remember, the number of micrometers for each of these units depends on which objective you are using. So this is how large my amoeba looks when I'm using magnification is. But since I haven't told you, you're supposed to say, I don't know. So not 45 micrometers, okay? All right. So new one, which will be